Hello everyone, we are Project 19048 with Caterpillar by the name of Automated Wire Winder and Cutter, and this is our virtual design day presentation. My name is Eddie Krasinski. I am a mechanical engineer and also the team lead.
My name is Yasmin Kulab and I'm system engineer.
Well, my name is Eric Beer, I'm a mechanical engineer.
Hi, I'm Jerry Chen, industrial engineer.
My name is Jesus Azueta and I'm an industrial engineer.
My name's Trip Turchik and I'm an electrical and computer engineer.
So currently Caterpillar utilizes a manual process to wind and cut different types of wire and lengths of wire, which is the image on the right. That's the device that they use currently, and this is at the Tucson and Peoria proving grounds. This process results in about 80 hours of manual labor costs per year per location, which comes out to about $4,000 a year, which they need to pay the employees to do this process. And our machine automates this and is designed to utilize 1/2-inch ribbon wire along with a 1/4-inch insulated wire.
Okay, so here's a illustration of our machine. On the right, we have a more of a clear view for our system components, and I'll be going through them in the next slide. So number 1, number 4, and number 9 are 80/20 housing components consisting in door assembly, brackets, and aluminum extrudes. Number 2, we have a supply spool holder. Number 3 is a funnel for wire guidance. Number 5, we have 2 rubber wheels powered by a stepper motor. Number 6, a linear actuator and cutter. Number 7 is our spooling subsystem that consists in our number 8 rotating serving tray with square head bolts powered by stepper motor. Number 10 is our power supply connected to our power outlet. All of these parts can be found on automated wire winder and cutter machine bill of material.
Here are the system and verification requirements. If you would like to read them all, feel free to stop the video.
So here's our approach to the problem. When we did research, we found that there wasn't actually a pre-existing machine that did this within the price range. However, we did find online that there were people that did do some prototypes for this machine, including the measuring system and the wire drive system. So then this left us with mainly just needing to create the collection subsystem, and then we were able to start the project.
So this is a summary of the analysis that we had to perform, and the greatest risk areas were friction requirements on the drive wheels, torque requirements on the motors, the wire movement rate, tolerancing issues, and then accuracy of wire measurement based on the motor step angle. And in conclusion, a spring was not needed. That friction requirement was already there based on the motor positioning. And along with that positioning came a torque of about 10.6 pounds, which is more than enough given the supply spools from Caterpillar. The motors provide a wire movement speed of about 65 feet per minute, which is more than enough. Our SolidWorks model showed no interferences between components, and this is also true in reality. And upon testing, the wire measured within 6% of the user's desired length.
So yeah, our system approach to prototyping was we wanted to test each subsystem individually even before 80/20 parts were received. So the motors and the cutter were both tested in the EC lab without any like structure to them. And then once we had the 80/20 in, some unexpected problems arose from testing the total system together. The wire kept on falling off the drive wheels. This was solved by making sort of a guide for it to go through the wheels so the wheels can move freely. The wire also got tangled before the cutter. This was solved by creating a smaller base on the cable cutter so the wire had more room to go through the cutter. And then the collection bin we knew was going to have a whole bunch of problems with it, and we actually just tested that by adding a cylinder on the top of the rotational bin. This is a video of our working product.
All right, so we have built our machine. We've already done the loading phase, which is putting the supply spool in and feeding it through all of these different components till a little bit sticks out of the end of the cable cutter. And then Caterpillar is going to have to do this every single time they reload a new one of these. And then once you do that, you head over to the laptop.
So yeah, you can plug in the machine and then it's kind of waiting for an input. Right now it's waiting for the input to be changed. We're going to do 60 inches, which is 5 feet for 2 counts. Then you go down here, you press this upload button. After that, it should take about 3 to 5 seconds for it to start. It might jolt a little bit to kind of make sure that it's initialized, and then it'll start going. So there's one. There's two. So once that's done, take this bucket off. Let's grab these. And then we'll head over to the tape measure to show you that they are 60 inches. As you can see, they're nearly the same. 60 right there. So I'm like maybe half an inch, 3/4 inch off. And that's it.
So here we're giving you our budgeting and cost summary in the slides. Overall, we have the total grand cost of $3,361. The reserve of the amount of $639 proves that we're under the budget given by University of Arizona. Here are the touch points that we delivered to our sponsor, which is the entire machine along with the replacement blades for the cutter, the authorized instruction manual, the contact information of all our team members for the future troubleshooting guideline, and we also recommend that Caterpillar purchases a mobile cards for the ease of use.
Surprises and lessons learned. A rotary encoder was to be used for measurements, unnecessary due to flexibility of top motor. Due to cable cutter manipulation, our machine works for any copper-based wire less than half in diameter. Lessons learned, designs rarely work for first time. Always order parts as early as possible. Clear communication makes for the best teamwork. Safety and environmental. Feel free to read them all.
And on behalf of all of us, thank you for your time.